Projectile motion describes an object that moves under gravity alone once it has been launched. This motion splits into two directions that are perpendicular to each other, horizontal and vertical. The horizontal direction moves at constant velocity because there is no force acting sideways. The vertical direction moves with constant acceleration because gravity pulls the object downward the whole time. These two directions are only linked by one shared quantity, and that quantity is time. Here is a two-dimensional view of the path, a curve that starts flat and bends downward, and here is the same path shown in 3 dimensions, so you can see the same curve from another angle. Now let's look at a worked example. A ball is projected horizontally at 15 meters per second from the top of a cliff that is 20 meters high. Step 1 is to solve the vertical motion in order to find the time taken to fall. In plain words, the vertical distance fallen equals the initial vertical speed times time, plus 1/2 times gravity's acceleration times time squared. In symbols, this is s equals ut plus 1/2 at squared. Because the ball is launched horizontally, its initial vertical speed, u, is 0. So the formula simplifies to s equals 1/2 at squared. We now put in the known numbers 20 equals 1/2 times 9.8 times t squared. Multiplying 1/2 by 9.8 gives 4.9, so 20 equals 4.9 times t squared. Dividing both sides by 4.9 gives t squared equals 20 divided by 4.9, which is approximately 4.08. Taking the square root of both sides gives t equals approximately 2.02 seconds. Step 2 is to solve the horizontal motion using this same time. In plain words, the horizontal distance travelled equals the constant horizontal speed times time. In symbols, this is x equals v times t. We put in the known numbers, x equals 15 times 2.02. Multiplying 15 by 2.02 gives x equals 30.3 meters. Now for the check step, we confirm that both answers make sense. 2.02 seconds is a small, sensible time for a 20-meter fall under gravity, so the vertical answer looks correct. 30.3 meters is a reasonable horizontal distance for a ball moving at 15 meters per second for about 2 seconds, so the horizontal answer also looks correct. Both units match what we expect, seconds for time and meters for distance, so the final answers are confirmed. Time equals 2.02 seconds and horizontal distance equals 30.3 meters.